All right, math leaguers, we're back. I'm back here with my trusty assistant, Tristan. Um, we're kind of running out of math, math puns here. But for this week, this is the week one of session 2 wrap up, where I'm just going to go through a bunch of the problems that you've already done. I'll also be sending out the answers so you can see which ones you missed and what the right answer was. And thanks for your patience this week. We had some delays because we had some people sign up really late, like right at the end of week 1, and we had a couple of little issues with the transition from session 1 to session 2. So anyway, we extended it a little bit. Hopefully you guys had a great week, and good job. And like I said, like Tristan's been here for some good math puns, like, he's a Maltese poodle, so he's good at multiplying, and he thought the problems were a little rough. So we're running out of math puns here, but you know what? I think that you're going to help them develop their math skills, and their math skills are going to go right through the through the roof. All right, good job, Tristan. All right, so this week 1, it gets worse and worse every week. Week 1, the first problem was there was a person, Olga, who gave away 50% of her cookies to one person, 20% of her cookies, not 20% of the remaining cookies, just 20% of her cookies to the other person. So she gave away 70% of her cookies. She kept the remaining 15 cookies for herself. So the 30% that she had left was 15 cookies. So 30% of the cookies is 15. 0.3 times C, I did a C for cookies, is 15. I divide both sides by 0.3, and I get the original amount of cookies was 50. Now again, you don't have to do this algebraically. You could do a lot of guessing and checking and things like that. But anyway, it asked how many cookies did she give to Marina. She'd given 20% to Marina and 20% of 50. Well, what's 10% of 50? 5. So 20% of 50 is 10. All right. The second question was, there was a girl, Sabrina, who was 8 years older than Ewan. Again, you could guess and check this whole thing, but we could do it algebraically. In 3 years, so Sabrina plus 3 would be twice as old as Ewan. Twice as old as Ewan is at that time, so Ewan plus 3. We distribute that. 2 times E is 2E, 2 times 3 is 6. We replace this S for Sabrina with E plus 8 because they're the same. And then we just solve a simple math equation. I subtract E from both sides, I get 1E. I subtract 6 from both sides, I get 5. If Ewan is 5 at the beginning and Sabrina was 8 years older than him, Sabrina was 13. Number 3 was a little bit hard. It said that there is a regular polygon whose degree angle measures is 135 degrees. So we know that the formula for the sum of all angles of a polygon is the number of sides minus 2 times 180. But then, how much is each angle worth? Well, it's if you then divide by how many sides there are, because all the angles will be the same, you'll get the degree measure of the angle. So the formula n minus 2 times 180, and then divided by n is 135. Now, again, if we don't have the algebra background, there's more we can do, but for this, we can multiply both sides by n, distribute here, so 180 times n minus 360 is 135n. I multiplied both sides by n to clear that out of the bottom. I subtracted 135n from 180n, and I got 45n. I added 360 to both sides. I got 45n is 360, n is 8. All of that work just to find out that it's an octagon. Then, how many diagonals does it have? Well, I don't know if you remember how many diagonals, there was a formula. The number of sides times the number of sides minus 3 divided by 2. So the formula is n times n minus 3 over 2. So 8 times 8 minus 3, 8 times 5 is 40, divided by 2 is 20. And then there's also that other way, when we're remembering how many diagonals a certain type of polygon has, that does form a pattern. A 4-sided figure has 2 diagonals, a 5-sided figure has 5 diagonals, a 6-sided figure has 9, goes up by 3, up by 4, up by 5, up by 6, 20. Kind of cool. All right. Next few problems. All right, number 4 was, what is the sum of the numerator and denominator for this repeating decimal? 0.2111111. Okay. So what do we have here? We have 2 tenths, right? This is in the tenths place. We also have 1111 repeating. Now that's one of those things that you just got to know. 0.1 repeating is 1/9, okay? Every place value is a tenth of the place value before it. So we have 1/9 of a tenth. Of is multiply. So that's 1/90th. We get a common denominator, so 2 tenths plus 1/90th. We get a common denominator, 90. 18/90ths plus 1/90th is 19/90ths. And it asks, what's the sum of the numerator and denominator? So 19 plus 90 is 109. Number 5 is a simple one. I mean, obviously you probably could have just looked it up, but what's the number, actually the sum of the faces plus edges plus vertices of a triangular prism? Well, I drew one here. The faces is kind of a little hard to do, but there's one on the bottom. There's kind of 3 going around, 1, 2, 3. And then 2 on the sides, like that triangle, those are faces. 5 faces. The vertices, 6, I marked those in red, 1, 2, 3, 4, 5, 6. And the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. We add them all up, that's 20, okay? Number 6 was, the ratio of boys to girls in a room is 7:4. There's 44 kids. Well, think of it like this. They're walking around in groups of 11. 7 boys for every 4 girls. So if we think about it, that's 11 kids in a group. If there's 44 kids, that's 4 groups. Every group has 7 boys, so 7 times 4 is 28. Okay. Question 7 was just a little bit weird. Question 7 was, how many different integers can you make from the difference of 2 distinct members of the set? Now, distinct meaning 2 different members, so like not 1 and 1, right? Of the set of 1, 2, 3. Okay, so how many different integers can we make from that? Well, we can do 3 minus 1 is 2. 2 minus 1 is 1. You could also do 3 minus 2, but that's also 1, so that's not another integer. And then we got 1 minus 3 is -2, 1 minus 2 is -1. 2 minus 3 is also -1, so that's not another integer. So there's actually 4 integers total that you can make. Okay, I'm going to skip a couple problems here. I'm going to skip to questions 11 and 12. And we'll come back to 8 and 9 and so forth. Hopefully this isn't too small. Hopefully you can see this. Question 11 was, you cut off, there's an 8 centimeter equilateral triangle. You cut off a section that's 3 centimeters each. What is the perimeter of the resulting trapezoid? Right here. Well, okay, so if this is 8 and you cut off 3, then this right here is 5. This is 3 because that's cut off there. This is 5. This is 8. So you just add up 3, 5, 8, and 5, 21. Then it asks for the area of this resulting trapezoid. Now that's pretty hard. In the hints video, during the midweek hints last week, I used something called Heron's formula. If you saw that, great. Go back and watch it. It's pretty cool. But there's another way to do it as well. Okay, so we know that this is 3. We know that this is 5. We know that this whole thing is 8. Right? But how do you find the area? For the area of a trapezoid, you need a height. And the problem is this dotted line here, we don't know the height. Okay, so how are we going to do that? Well, what I did this time is I dropped down what we call an altitude. So we had a 90-degree angle right there. So now we have the height. But what we don't have is a number for it, right? So, well, let's see if we can work it out. When I drop another altitude down here, what I've done is I've created a line here that's 3 that split this bottom section. Well, the bottom section is 8. So it needs to be 3 plus 5 is 8. So it split this into, if this is 5, that's 2.5, and that's 2.5. I know, this is tough, right? Okay, so then if this bottom little thing of this triangle right here is 2.5, we can do a Pythagorean theorem for this triangle. A squared, leg squared plus leg squared is hypotenuse squared. So 2.5 squared plus, we'll call it B squared, equals C squared, 5 squared. 2.5 squared is 6.25 plus B squared is 25. We subtract 6.25, we get B squared equals 18.75. We take the square root of 18.75 and we get approximately, because we're just trying to round to the nearest whole number, we get approximately 4.33. So the height of this line is 4.33-ish. Then we can do base for the triangle, 2.5 times 4.33 divided by 2 is approximately 5.4. Well, this triangle would be exactly the same, 5.4. Hoping you can still see all this. All right, so we got 5.4, 5.4, that's 10.8. Then we have a rectangle with a base of 3 and a height of 4.33. So the area of the rectangle is about 12.99, about 13. So if we add up 5.4, 5.4, 10.8, which is basically 11, 12.99, which is basically 13, the nearest whole number for the area is 24. And, all right, should we go through the others? Let's go through the others. All right. Yeah. Okay. Which ones haven't we gone through yet? Number 8 was, number 8 problem was the one that said x at y can be defined as, you know what? Mr. T is just going to send you out the answers for the rest of them. If you have any questions on number 8, number 9, number 10 we didn't go over. You know what? Let's do number 10. I like number 10. Bob can paint a house in 10 hours by himself. Joe can also paint a house in 10 hours by himself. Sanjay can paint a house in 14 hours by himself. And Linda can paint a house in 14 hours by herself. How long would it take them to paint the house all together? Well, what we can do is there's 4 people. 10 hours, 10 hours, 14 hours, 14 hours. What we can do, let's take these 2 people, Bob and Joe. If they can both do it in 10 hours by themselves, if they're working together, it would take half the time. Together, they could do it in 5 hours. Stands to reason, right? Sanjay and Linda, 14 hours individually, Together, it would take them 7 hours. Then we can use that formula, A times B over A plus B, and we get 35 over 12, which is 2 and 11 twelfths. 2 and 11 twelfths. Well, what's a twelfth of an hour? 5 minutes. So 2 whole hours, which is 120 minutes, plus 11 5 minutes, which is 55 minutes. It's 175 minutes. Okay? All right. I think we're good. I'll send you out the answers to the rest of them. And yeah, rest of them are easy. Number 15. We'll do number 15 really quick. Okay, that was a super easy one. It says x plus 4 times x minus 6 times x minus 4 times x plus 5 equals 0. Well, think about it. When you multiply 4 things and the answer is 0, one of those things has to be 0. So either this thing is 0, and for this thing to be 0, x would have to be negative 4. X minus 6 could be 0, so x would have to be 6. X minus 4 could be 0, so x would have to be 4. X plus 5 could be 0, so x would be negative 5. Okay? And then it's saying, what's the sum of all the possible answers? Well, I got 9 negatives and 10 positives. 1 is the answer. This was number 15. All right. Great week, guys. Looking forward to seeing you for the rest of the time. Keep your eye out on the posts. Keep your eye out for the math jokes. Keep your eye out for prizes and raffles and for the weekly bonus challenges, etc., etc. See you guys later.